welcome to Easy Elimu Learning Simplified. My name is Eric. I'll be taking you through this topic area, and for this lesson, we're going to cover area of a rectangle. So we want to start by looking at what a rectangle is, and then we want to see how then can we find the area of a rectangle. We have a few questions we'll be going through just to help us with illustrations on how that can be, on how we find the area of a rectangle, and then of course we have some questions at the end of the lesson in the form of assignment just to help you practice and to help you gauge on your understanding of the concept as discussed during this lesson. So such a figure as displayed on the screen is what we call a rectangle. We have a few characteristics that will help you, identify what a rectangle is. So we have one of them is like we have the opposite sides being equal, like this side here. Maybe if we label this A, B, this is C, and then this is D, then we could talk of the line AB opposite to BC, but then they're equal in length. So we also have the line BC being equal to AD, and you can see the two are opposite to each other. And another special characteristic that this has is that all the interior angles are 90 degrees each. So those are some of the characteristics that you need to highlight to help you identify the figure, like a rectangle. Every time you see such, then you know that is a rectangle. So you want to see how can you find the area of such a figure, So we have the formula here. Say area is equals to length times width. So the shorter side here is the one we are calling the width, and the longer side is what we're calling the length. So longer side is length, and the shorter side is called the width. Like BC here is a width, and AD is also a width. So this formula can be used to help us find the area of a rectangle, having mentioned some of the characteristics of a rectangle. So after you have looked at the characteristics and you've decided that this is a rectangle, like maybe opposite sides being equal, all the interior angles being 90 degrees each, and then you have to identify the right formula that can be used to find the area of such a figure, which is length times width. So you can either write it in full or use the symbols L and W as displayed on the screen. So we have a few examples to help us see how we can apply that formula. So the first example we have is displayed here, number 1. So a photograph measuring 14 centimeters by 10 centimeters is fixed inside a rectangular frame of dimensions 24 centimeters by 18 centimeters. So what is the background area of the space not covered by the photograph? So the best way to go about this is to first of all maybe have a rough sketch of that given information. Maybe you try to sketch some diagram that will be reflecting the information that is provided in the question. So we have two rectangles here. We have a photograph, which is smaller in size, and then we have a frame, which is larger, wider compared to the photograph. So you draw the two. So we have the frame, which is bigger. So this is our frame. So the frame has dimensions 24, which is the length. So you see we have two dimensions given, 24 and 18. So we said the longer length here is supposed to be the length, that is the longer side, and then the shorter one, the value that is given, if you compare 24 and 18, 24 tends to be longer, you see. So that becomes the length, and then 18 here is shorter, so that becomes the width. So we have 18 here. Now, the picture or the photograph is supposed to be inside the frame, so you draw the photograph here. So this is our photograph, and we are given the dimensions as well. So we have 14, and then we have 10. See. So the question that you're supposed to answer here, or the problem you're solving, is that what is the background area of the space not covered by the photograph? I want to try and shade that space that we are trying to find its area. So that is this space here. So that is the shaded region. That is the area we are trying to find. So how do you do it? So simple terms, we'll just find the whole area minus the area of the unshaded, So maybe I can talk of A here being A1 minus A2. So A1 here is the larger area, or the area of the frame, and A2 is the area of the photograph, the unshaded area. So let me try and do that. So I have A1, that is the area of the frame, which is 24 by 18. So 24 by 18. So what is this totaling to? So we have 24, you multiply by 18. So this is about multiplication of natural numbers that we have done in one of our previous videos. You can always check if possibly you missed out on that. You'll be able to see how that is done. But basically we start with, remember the numbers down here are both multiplied by, like we have 8 and we have 1. So both of them you multiply by all the numbers up there. So starting with 8. So 8 by 4 is 3, 2. So 2 carry 3. And 8 by 2 is 16 plus 3 is 19. Now when it comes to 1, we multiply the numbers up there by 1, but now we treat this as 10, meaning as we're using the total value, total value of this digit here, 1, but the total value here is tens. I mean, you take 1, you multiply by 10, so the total value is 10. So when you're multiplying by 10, you simply multiply by 1 and then you add the 0. So what I'll do, I will add that 0 first. Yes, then you multiply by 1. So 1 by 4 is 4, and 1 by 2 is 2. And then now you can add the two products. Up there we multiply, down here we sum up. So 2 plus 0 is 2. 9 plus 4 is 13, 3 carry 1. And 1 plus 2 is 3 plus 1 is 4. So we have 432 as the answer here. So it means our A1 here is equals to 432 square centimeters. Remember, area is measured in square units. So again, we do A2, which is now the area of the photograph. That is the unshaded area, and that is supposed to be, again, length times width. So length is 14 and width is 10. Now multiplication by these powers of 10 is usually easy. So you simply add 0 to this 14 here. So we have 1, 4, and then you add 0. So 140 square centimeters. Now we need to do the difference between the two. So we have A1 minus A2. So A is equals to A1 minus A2, both of which you have calculated. So A1 is 432. 432 minus A2 is 140. So this is 140. So you need to do the difference. Again, you can arrange the numbers vertically. So we have 432, and then we are subtracting 140. So this is subtraction. So 2 minus 0 is 2. 3 minus 4 is really not possible. So what you do, you borrow 1 from 4, you put it here, it becomes 13. 13 minus 4 is 9. So this is 9. Here we already borrowed 1. We have 3 remaining here. 3 minus 1 is 2. So this becomes the difference. So it means our area here is 292 square centimeters. So that is the area that you are looking for, the area of the frame that is not covered by the photograph. We are trying to find what is the background area of the space not covered by the photograph. And that is how you go about it. So we have another example here. There is now a mat that is measuring 10 meters by 8 meters, covers an area inside a floor, measuring 14 meters by 12 meters. Find the area not covered by the mat. So this is more or less the same as the previous example, only that the context now is different. So again, you try to do a sketch of the given information. So you have this, and then you draw this. So this is the mat. The mat has the dimensions 10 by 8. That is 10 being the length and 8 being the width. And the floor has the dimensions 14 by 12. So 14, the longer length here becomes the length, which is 14 meters. And the other one is 12 meters. So this is 8 meters. And the other one is also 10 meters. So just like we did the previous example here, we are still just trying to find the area of the shaded region. So we'll still do the area of the whole, the bigger rectangle minus the area of the unshaded, which is also rectangular in shape. So basically, you are trying to find the area of a rectangle using the formula length times width. So we have A here is equals to A1 minus A2, So A1 is the area of the floor, which is the bigger area of the bigger rectangle, and A2 is the area of the mat, which is the smaller area, the area of the unshaded, So A1 is the bigger rectangle, that is with dimensions 14 and 12. So we have length times width again. So we have 14 multiplied by 12. So what do you get when you do this? So let me try and do it up here. So I have 14 multiplied by 12. So again, the same thing we did when you are doing the previous example about multiplication of natural numbers. So starting with the unit digit. So every number down here multiplies both numbers up there. Starting with 2, so 2 by 4 is 8, and 2 by 1 is 2. Now multiplying by 1, this is treated as 10. So you're supposed to multiply by 1 and then you add 0. So what I'll do, I'll add the 0 first. So 1 by 4 is 4, and 1 by 1 is 1. You fill up the spaces left using zeros, and then you subtract. You add the two products. So up here we are multiplying, down here we are adding. That is addition of the two products. And again, if you are unfamiliar with that, you can check from our previous videos on that multiplication of natural numbers. You'll be able to see how that is supposed to be done. So addition of the two products you start from the farthest right hand side, So 8 plus 0 is 8. 6 plus 4 is, 2 plus 4 is 6, and then 0 here plus 1, that is 1. See. So that is our A1, which is 168. Now we move to A2 again, which is the area of the unshaded region. Again, it is length times width. So the length of the unshaded region is 10, and the width is 8. So the product of the two, multiplication by powers of 10 is usually easy. You simply add the 0. So 8 here, simply add 0. So 8, and then you add the 0. That is square meters. Square meters. So we are supposed to do this, the difference between the two. So you have A being A1 minus A2. So A1 is 168 and A2 is 80. So again, you can arrange them vertically. So we have 168 minus 80. So this is 80. So it is subtraction here. So 8 minus 0, that is 8. And here we are subtracting 8 from 6. So that is not really possible. So we borrow 1 from 1, have 0 remaining there. Taking that 1 to 6 becomes 16 minus 8 is then 8. So it means our A here, which is the difference, should be 8 square meters. So the area of the unshaded region, that is the area not covered by the mat, that is supposed to be 8 square meters. So we have another example here. There is now a floor of room measuring 8 by 4. And then we have square tiles measuring 20 centimeters by 20 centimeters, which are used to cover the floor. So how many of these tiles are required to do that work? So here we'll take the total area of the room or of that floor, and then we divide by the area of each tile. So we are talking about n. So I can talk about the total area of the room being capital A, and area of each tile being small letter a. So you try and find both. They are both rectangular in one way or the other. And talk about the rectangular room, it measures 8 by 4. Also, we have this square, which is also just some form of a rectangle, being that it has certain characteristics of a rectangle, opposite sides being equal, each of the interior angles being 90 degrees. So let's find capital A here, which is the length of the floor. So that is length by, the area of the floor, which is length by width. So the length is given as 8. But now that these other measurements down here, remember we're going to divide the two. The measurements that are given down here are given in centimeters. So we'll have to convert the other measurements there to be in centimeters as well. That is what we did in the previous previous lesson, we were talking about unit conversions, and we were able to look at how you are able to convert units from meters to centimeters. So when you are converting these units from meters to centimeters, you simply multiply by 100. And if you multiply 8 here by 100, it will be 800. And then the other one is 4. Again, you multiply by 100, that is 400. Possibly, it will be more convenient that I leave them in this form, see, without really finding the value. So let me find what small letter a is, and that is the area of each tile. Remember, it is square in shape. So we have 20. Again, it's just some form of a rectangle. So you can just use the same formula, length by width. The only difference between now this square and the other rectangle that you're talking about is that now length is equals to width. That is the only difference that is there. So we have 20 times 20, and again, I would prefer to leave it in this form because I need to do the division. Remember, this is not the final answer. So if this was the final answer, then I would have tried to evaluate by multiplying maybe 2 by 2, and then I add the zeros. You see, 2 by 2 is 4, and then you add the 2 zeros. But now, there is division that I want to do here. So because of that, it will be more convenient that I first of all leave them in this form before I can simplify them further. Maybe I'm going to do that simplification when I'll be doing the division there. So it's more convenient to do that. I know you can still multiply first, you find the value, and then you divide, but then that will be really inconvenient. It will take you a longer time to do that. So now I have the number of tiles that I'm looking for. So that is capital A again divided by small letter a. So capital A here represents the size of the floor, and small letter a represents the size of the of each tile. So this is 800. That is capital A multiplied by 400, and then this is 20 multiplied by 20. So we want to see how you can do cancellation. Again, we have done multiplication of natural numbers, division of natural numbers, and whatever we have that is displayed at this step, it was under combined operations, where we have multiplication and division done at the same time. We did something like this. Again, you can check on our previous videos. You see how that was done. At least you'll be able to have some idea on how you can go about that. So all the same, we can still try and do. So first of all, maybe I'll start by cancelling the zeros. And then now I have 2 goes there, 1, 2 goes there, 40. Again, 2 goes there, 1, 2 goes there, 20. So you see, this is easier. Just multiply 4 by 20, you see. That is easier compared to when you multiplied 800 here by 400. Again, you multiplied 20 by 20. And then you after that, you come back and you try to do the division. It will take you a longer time as compared to when you just do this. You know that the values that you're getting here, you still have to use them somewhere else. Especially when it's division, it would even be better that you leave them in that form first, and then maybe cancellation can be done at this level. So let's see. So now I have 40 by 20. You see, now again, I'll just multiply the numbers. Again, we have done this on our previous videos when you're talking about multiplication of natural numbers, and especially multiplications by powers of 10. You can check that on our previous videos. You'll be able to see how that is done. So what we did basically is just multiplying the numbers and assuming the zeros first, and then you add the zeros thereafter. So you have 4 by 2, which is 8, and then I add the 2 zeros, and that's how you get the answer. So here the units are supposed to remember the units are supposed to be related to the question that is asked. So we have how many of these tiles are needed. So we need 800 tiles. 800 tiles. So that is how you go about that. And our final example is here. We have an area of 10 square plots. We have square plots, and then there are 10 of them, and the total area of all this is 160 as. Find the length in meters of each side of each plot. So we will try to find the total area, which is equals to 160. 160 here you multiply by 100, because 1 here is supposed to be 100 square meters. So you multiply this by 100. See, so the total area is given by 16,000 square meters. So how do you find this area? This area is supposed to be the number of plots multiplied by the area of each plot. So small letter a represents the area of each plot. So this is again 16,000 square meters. So the number is 10 multiplied by the area of each plot. That is going to be 16. 16,000. So what I do is I'll divide both sides because I'm trying to find this area, the area of each plot. Remember, each plot is square in shape. So when I have the area, I have the shape, I'll be able to know which formula should I use, and then I do the substitutions in the order in which the formula is written, and then from there I'll be able to find what I'm looking for. So we divide both sides by 10. So left hand side, I have a remaining, the other side, this cancels, and then I have 16 and the 2 zeros. So this area here is 1600, but being that it's a square in shape, remember, we are talking about a square. So length by width, but square has a special characteristics as we are able to see in the previous example, whereby now length is the same as the width. So you can substitute W, remember, you can substitute W here for another L. So let's see. So length times width is equals to 1600. But W here is the same as the length, like all the sides are the same. So I have L by L is equals to 1600. So this is going to be L squared is equals to 1600. Now, for me to find the value of L here, I'll have to do the square root of 1600. Remember now we talked about square roots of numbers by process of prime factorization. You can still use the tables to help you find the square root of 1600. But you can still use prime factorization to help you find that. So let me try and do that. Let me try and use prime factorization. So prime factorization, we have also done that. You can check and see how that is done. But basically, we just need to express this number in power form, this number here, as a product of its prime factors in power form. So let me try and see. So I have 1600. So 2 goes into 1600, 800, 2 goes into this, 400, 2 goes into this, 200, 2 goes into 200, 100, and 2 goes into 150 times, and 2 goes into 50, 25 times. So we have 25 and the journey continues. So 25, we have 5, 5. So we have the square root of 1600 being equal to, so you need to multiply 2 how many times? See, this is 2 how many times? So we have 2 once, 2 twice, 3 times, 4 times, 5 times, and finally 6 times. So 2 power 6. Then you multiply by 5 2 times. That becomes 5 power 2. So this is square root. So when you're finding the square root, what you'll do is simply divide the powers by 2. So if you're dividing the powers by 2, that becomes 2 raised to power 3 and then 5 raised to power 1. So I'll try to break this down further so that I have 2 by 2 3 times, or 2 multiplied by itself twice. 2 you multiply by 2 and another 2. And then we have 5. So maybe I'll group them in groups of 2. So I multiply this and also multiply this. And what do I get? This is 4 and the other one is 10. So 2 by 2 is 4 and 2 by 5 is 10. So 4 here by 10 is 40. It means the L that you are trying to find is 40 what? 40 meters. Yes. So that is how you go about it. That is the length.